When you look at the NTSF, it has the boot sector. Now, the boot sector contains booting information. These are system files that are fundamental for the booting of your computer or for the starting of your computer. And that is where we are talking about here the boot sector. Hold information about the volume. But what we are saying here that the boot sector contains files or system files that are mandatory for the booting of your computer. Now, when you look at the master file table or the master file table, we are saying files that record information about each files in the volume. Yeah. Record information about each file in your storage. Now, when you look at the MFT zone, the master file zone is basically reserved for the expansion of the master file table. This one, master file table. As you continue increasing information in your storage, then it is the master file table zone that will continue being adjusted. Yeah, so we're saying here that we have the master file table zone, or what you're calling the MFT zone. It is reserved for the expansion of the master file table. The master file table record information about each file in the volume. And then we have what you call the file system, where files are allocated within the volume. Very important. Now we have these terms that you'll always find, these terms, terms. When you're dealing with files, you have what you call the file lock. File lock. Of course, when you're talking about a file, we are saying that if a whole file is locked, it will prevent other processes from accessing any part of that file. For example, when a cashier is operating a record or a particular transaction in the supermarket, that particular transaction cannot be accessed by another person. That is a file lock. You're preventing others from accessing any part of that file. Now when you talk about the write lock, we are actually preventing other processes from modifying. Yeah. So one cannot modify, one cannot write into that particular file. So those are two terms that you'll always find when you're dealing with files. I don't know whether there's somebody in the waiting. Yeah. So when you look at the advantages of NTFS, the new filing system that we are using in our operating system that we are using today, with the big storage that we are using today. Number one is that they are self-healing. Yeah. In the old days, we used to do scanning of our disk every now and then, but nowadays we don't, because we are sure that the system is doing that in the backdrop. Yeah. So we are saying here they are self-healing, a mechanism to monitor and amend what you call logical and physical errors in the disk. Number two, it allows for higher capacity storage than FAT, higher space for storage than the file allocation table that used to be there in the older days. Yeah, and that becomes an advantage. Number two and number three is again security advantages of there is the aspect of security, and I think we've mentioned the aspect of compression of files. You can be able to compress files. I think we mentioned it here, up here, where we are talking about the aspect of, let me just look at it. You can be able to compress, you can be able to even, you can be able to compress files, especially when you have the NTFS. And if you look at, even when you're creating folders, you can zip folders, or you can compress, yeah, files, and that becomes an advantage with the NTFS. Why are we compressing? So that we can be able to save our storage. Now, when you look at the file system software architecture, I've changed this diagram. If you look at our notes, it was not this clear. I'd actually done it more like a matchstick diagram, but I've tried to modify it so that at least we have a clear understanding where the user is. Of course, the rest of the other items remain, where we are talking about the user programs are many. It can be Word, it can be Excel, it can be any document any application that you're using. Yeah. So we are saying here that there are various file system software architectures, and we'll be looking at the various components of this. Okay, I can see Mosembi asking about is there a difference between what you're referring to as NTFS. You'll find people talking about network filing system or new technology filing system. Now, you'll find people misspelling these terms. Basically, when you check, you'll find it is network filing system. Others will be talking about new technology file system. Basically, I don't think there is a misconception where somebody just says a new technology. Yes, it is a new technology, but basically it is network filing system, not new technology. I hope I've answered your term. So when you're writing in your exam, you should not talk about a new filing system or what others will call new filing system technology. No. It's basically network filing system. Yeah. Now, when you look at the file system software architecture, it's similar to what you have in your notes, but I've actually changed this diagram to make a bit of more sense. Let me admit more students coming on board. So we are saying here that we have the disk device driver, this one. We are saying that it is the lowest level and communicate directly with the peripheral devices. These peripheral devices can be your printer, can be your scanner, can be your DVD player that is attached to your device, wherever. Even if it is your hard disk, it must come with the device driver. So we're saying it is responsible for starting input-output operation on a device. Yeah, processes the completion of an I/O request. Yeah, so it's important. So
excuse mwalimu, hatukusikii. Kuna venye umejimute.
Okay, so that is right. Now we're saying here that when you look at the various file systems that you're going to use, for example, if you're going to use a magnetic tape, you have to access information sequentially, one after another. If you want to go to song number 5 and you have a magnetic tape, you have to go through track number 1, track number 2, 3, up to the track that you're interested with. So we are saying here that when it comes to the access method, we are saying that it provides a standard interface between application file system and the device that holds data. If you're going to use a hard disk, that is a direct, that is a random access, that is a hashed access. So different access methods will be determined by the kind of storage media that you are using. So for example, at the user application level, for example, if you're playing music from a flash disk, yeah, that is hashed. It is direct. It is random. You can access any song anytime. If you're using a magnetic tape, that is sequential. Yeah. So it will depend on the kind of storage media that you're going to use, is the one that is going to determine the kind of access method that you're going to have. So we're saying here that as we look at this access method, there is also the file organization and access. Of course, if you break this term, file organization, how information is organized and the kind of media that you're using will basically determine how you are going to access that information. Let me give an example in our own rooms that we have our own personal items. If you bring clothes from the line and heap them somewhere and you're looking for a pair of socks, it means that you have to do an exhaustive search. But if you bring your clothes, fold them properly, organize them properly, place them in their respective places, you can do what you call direct access. You can access that pair of socks without going through the rest of the other clothes. So we're saying here that the file organization will basically determine the access method. So we're saying logical structure of record is determined by the way in which files are accessed physically. Organization of files in secondary storage, on blocking strategy and file allocation strategy. So how you will store your information and the kind of storage that you're using will basically determine the access that you're going to use, whether it is file, whether it is index, whether it is index sequential, and the others. Now, what are the factors to consider when you are choosing a file organization? Number 1, It is the shortest access time. You want to make sure that every time you want to access information, you take the least time. Simple maintenance. You don't want the operating system to spend all the time looking for information. If you want to update that information, it must be done in an easy way. Again, how much storage am I going to use? It must ensure there is economy of storage. And again, there is reliability. And we all know what is reliability. Getting the most out of the least. You store your information, you access it without struggle, you save using the least amount of effort, and you access it without wasting time. So we're saying here that the 5 factors to consider when you're choosing a file organization are very important. And this tells you why magnetic tapes are becoming obsolete. Because they have long access time, they are difficult to maintain. If they gather moisture from the environment, they become destroyed. They are difficult to update. There is a lot of uneconomic use of the storage because of what we call the interrecording gap. And then it is not reliable. You cannot move from track number 1 to track number 6. And that is why now people are going to mem cards. Of course, even the CDs are becoming a bit more obsolete. People want to use either flash disk, they want to use their mem cards, because you can be able to store much information and access it without struggle. Now we have 3 types of levels of access control. These ones, levels of access control. Now, the first one is what we call the system. Yeah, we are saying here that with the system, this is basically at the operating system level. At the operating system level, where we are saying, for example, in my laptop or in your laptop, you have your username and password. So it is the operating system. It is the operating system that is controlling who will access what at what time. Yeah. So that is at the operating system level. Now, at the directory is basically at the folder level, in another language, folder level, where you're saying, for example, if you have to access the information that is in a particular folder, you have to enter your username and your password again, or you have to enter a password to access files that are stored in that particular folder level. And finally, the last access level is at the file, where you have to enter what? A password. In a doc. That is, the file level is at the, basically at the document level. The document level, where you're saying, like for example, this Word document, I could have put a password. So even if you are to access it, it will ask you for what? For a password. So those are the 3 levels of access control that you'll find in operating system. For example, if I leave you with this laptop.
Excuse me, sir.
Yes.
Can you say that the files has the subdirectories?
The file has
subdirectories.
In the subdirectories.
Are the subdirectories present in the file?
No, they are in the directory. So if you have a directory here, the directory is a folder. Now, if you have a folder and you have other folders within those folders, you could also enforce access control within the subdirectory or within the very other subfolders. I hope we are communicating. So that if you have one big folder outside called exam, and you have other small folders, maybe for ICT and ethics, for operating system, for programming, so you can have even other access control within the other subfolders, but they will still be under what? They will still be under directories because they are folders. So you can have the big folder or at the root directory or at the root level. You could enter the password. When you go to the other small folders, yeah, you can also have other passwords that you're putting within those levels to control access, maybe for operating system. You have another password to access notes on programming. You have password to access notes on Pascal. You have password to access folder of ICT. Those are still directory levels. So those are very important. Let me admit others who are joining us. So we are saying at the directory level, yes, you could have many folders within or subfolders within the main folder, but again, they are still directories. They are still folders. So you can reinforce whichever access controls within those different subdirectories, or what you're calling the subfolders. Now, again, within those folder or that subfolder, those documents could also have what? Password. The document level. You're controlling access at the document level. Somebody to access that PowerPoint, they must have a password. Somebody to access operating system notes, they must have a password. So those three levels of access control are very important.
Another question.
Yes.
Can you define the term folder metaphor?
A folder metaphor.
Yeah.
Okay, maybe we'll handle it as we go by. We'll handle it as we go by. Let me note it. So we have different levels of access, and so we'll be looking at the folder metaphor in a short while. I think it was in one of the exams, and as we go by, we'll be handling it. So we're saying here that we have these three levels of access. Either it can be the system, it can be directory level or at the folder level, or it can be at the document level. I think we discussed file access control methods. Yeah, file access control methods in our previous lesson, or logical security measures. You remember, it can be biometric, it can be password, and I believe these ones are common because this, when you're dealing with a file, it's part of logical security. Yeah. So I would wish you post those questions here so that everyone can also note them. Yeah. You asked, the question was about what? File metaphor.
Yes, the question was about file metaphor.
Okay. Now we can continue. Maybe for those people who have their microphone on, maybe you can mute them. Now we can continue with the file organization methods in a disk. Yeah. Now we have various file organization methods. How is information organized? How is information arranged in a disk? So we say we have 4 major methods of file organization. Either it can be sequential, it can be direct, or what you call random. You can have serial, and you can have what you call sequential file organization. Now let's look at the first one, where we are talking about the pile. And we're saying here that the pile data is, you're just collecting data or accumulating data as it comes, with no respect to the relationship between one data and the other, with no relationship with the type of files or even the structure. So you're just accumulating the mass of data and save it as it comes. You're accumulating mass data. That is what we call pile. Data is collected in the order of arrival. Now, if you look at this, there are different sizes of data coming on board. Doesn't care the size or the type, you just bring it. So we're talking about variable in terms of length, in terms of set, in terms of chronological order may also vary. So it's quite simple. It doesn't follow any criteria. So records have no different fields and there is no structure. So you're just bringing it. So now the problem with this kind of file organization is accessing. You have to do what you call an exhaustive search. And that becomes a big problem. You take a lot of time. Now, the second one is what you call sequential file organization. Sequential. Records are stored, sorted, and accessed in a sequential order, either using a particular key. For example, in a magnetic tape, where you're saying you have song number 1, you can see here the diagram. So you can have here, maybe currently you're here and you want to move to the track number 1 here, or track number 0. Now, you have to traverse all the other records before you go to the final record. So we're saying here that sequential files are stored in a magnetic tape. And you all know the magnetic tapes. Rewinding and forwarding was one of the biggest problems. And especially in the old days where you're using batteries, it used to drain batteries. So you have to remove the tape and rewind it using a biro. For those people who found those kind of devices. So they're basically becoming obsolete because you're saying here that data which is stored sequentially can only be accessed sequentially from the beginning until you go to where the file is. So again, if you are at the middle of the tape and you want to access the first item, you have to traverse all the others before you go to the record that you're interested with. So we're saying here that it is called sequential access method, or SAM, and it is a time wasting. The advantage, it is simple to understand, easy to organize and maintain. Records require only a key field. You only want to go to song number 1, so you just go to number 1. Yeah, and then it is cheap media. Of course, the tapes were 50 bob. Nowadays, they are no longer in production, except for the big magnetic tapes that you're using for backup in our server rooms. So people are not using them at all, but they are still being used, especially for the server where you need a lot of data redundancy. You want to duplicate data. You want to create several generations of data. For example, you have a tape for the month of January. So you'll be accumulating your data in January. Yeah. So you'll find these tapes are not affected by viruses, because once you store your information, maybe where the red is, tomorrow you will come and store it here. There are no provisions of deleting the files that are here, not unless you do it willingly. But you keep on doing here Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, and you can continue on and on. So they're basically being used for backup, but they're not the best. So we're saying here the disadvantage is that the entire files can be accessed even when the activity rate is very slow. Entire file must be accessed. That means if you want to go to item that maybe let me give a song number 5, you have to go through song number 1, 2, 3, 4, up to 5. When you're in song number 5 and you want to go to song number 2, you have to traverse 4, 3, and that becomes a bit time wasting. Random inquiries are not possible. And then, of course, data duplication. In the old days, you'll find somebody with song number 1 repeated 5 times, and then somebody says there are 7 songs, yet there are only maybe 2 or 3. Others are being repeated. That becomes a big challenge. So you also end up wasting a lot of storage, yeah, because of what we call storage wastage. Because of interrecording gaps. So we have the third one we are calling direct, or what you call the hashed, or what you call the random file organization. This is what we're using in our flash disk, in our hard disk, in the modern storage devices. We are using now what you're calling direct, or what you're calling hashed, or what you're calling random file organization. So we're saying here that you are accessing information directly. For example, you just double click on a document and it comes, and maybe it is stored in a very different location from what is on your screen. So to access record stored randomly, a record key is used to search for the record. For example, if you look at this diagram, there is a key field, a particular key that basically looks for that location, or give you direction, or the address location. So we're saying to get a particular record, the input will be the key, the record key field. This could be the address location. In the day-to-day life, we call them, which name did you use to save? But basically, that name is for your information. But in the backdrop, it is the address location of where that information is stored. So we're saying here that, for example, if you look at the magnetic tape, magnetic disk, or even our hard disk, or even our mem card, they're basically using this kind of direct, hashed, random file organization. They are very fast. And that is why you find we're using them more and more often, because they will save you time. Information can be accessed and saved anywhere within the storage. And then it is quick, easy to update. And then you do not make what you call, you do not make use of indexes. You're using a key. The disadvantage is that expensive hardware and software resources are required. Of course, the programs that are being used to access that information basically will vary. Again, data can be accidentally erased or overwritten unless special precautions are taken. But I think this has already been done. But if you're not careful in reading the prompt messages that come on your screen, then you can end up losing your data. And then systems designed around this are costly and complex. Of course, with the new technologies that we are having today, it's no longer an issue because you don't program to open a file. You don't program to access a file. That has already been done. So the advantages outweigh the disadvantages, because nowadays these flash disks are becoming cheaper, mem cards are becoming cheaper, hard disks are becoming cheaper, yet very fast and also very big capacity. Now we have what we call the index sequential file organization. So you're combining the last two. An index, you have an index, yeah, the last two, you have an index, the one that we talked about here, sequential, you have an index and you also have what? You have a sequence. So it's a combination of the earlier two methods, only that an index is used to enable the computer to locate individual records on a storage media. You can be able to access information sequentially, and you can be able to access information randomly. So that's an advantage, and we're using them in magnetic drums. Yeah. Now, an index will help you to locate that file. A sequence, information is stored in a particular order. And as you can see here, in the diagram, you'll find that you have a key, yeah, assisting you to get the location. And you can actually move directly to where the information is, yet the information can be accessed sequentially. So you're combining the benefits of sequential and random at the same time. So it makes a better way of making sure there is less duplication and information is stored in a particular order. Now, the advantage of this is that record can be accessed in both ways. You can do random, you can do sequential.
Excuse me.
Yes.
Excuse me, sir.
Yes.
So we said that
there are two people talking, yeah? Is it Torrance or is it, who is this?
Torrance.
name? It's Torrance.
Yes.
Yes, sir.
Change your name so that we know who you are.
Okay, I was asking, you're saying that this index, they contain pointers. So I was asking, what are these pointers?
Pointers are basically directing you to where that information is stored, so that you don't have to
directly to the file.
They will show you exactly where information is stored. That's why they're called pointers. So you don't waste time looking for the information. Okay.
Yes, thank you.
Okay. So that's fine. Then we can continue. So now, when you look at the advantages of these index sequential, there are many. Of course, it's a combination of the advantages of the two. You can access them sequentially or randomly. You minimize duplication. Of course, there is less time in accessing a document. The disadvantage to the storage media is rather expensive. Let's mute our microphones. And then the disadvantage accessing records sequentially is time consuming. If you have to go sequential way, then you waste a lot of time. And then if you have to store information sequentially, then there is a challenge of redundancy. So those are the key issues that are handled under index sequential. We have what we call the serial. Now let's continue. We're talking about serial file organization. Now serial, we're saying record in a file are stored and accessed one after another. There is no regard for the relationship between the files, yeah? And serial, mostly it's information after another. And you're saying here that there is no regard for sequence. Record can be sorted in any way. This method of file organization can also be in magnetic tape, yeah? In magnetic tape. And so magnetic tape can either be serial or it can be sequential, either way. And we all know that the disadvantages that were in the sequential file organization will apply even for index sequential. Now let's look at file directories. Of course, when you talk about a directory, you're talking about a folder in another language. Yeah. So file directories basically will contain information, either the location, the ownership, and the attributes. Yeah. And if you, for example, go to any folder for that matter, and you right click on it, you'll find the attributes. Yeah. Maybe I can just go to one, even as we continue. For example, if I go to my folder here and go to properties, you'll find that the directory will give you information to do with the location, the size, how many files and other folders are contained, whether it is read-only, whether it is hidden, And even when you go to advanced properties, you can see either whether it is compressed or it is encrypted.
Excuse me.
Yes.
I'm not able to see your screen.
No, I'm not sharing the screen. I just left the file directories to open a folder and try to read what is in the folder.
Okay, fine.
Yes. So we're saying here that when you right click on a folder, there are many things that you'll see. You'll see the size, the location, and the owner. If you go to advanced, you will find whether it is encrypted, whether it is compressed, whether it is read-only. Those are the things that you'll find there. So we are saying directory contain information about the file, including the attributes, the location, and ownership. This information is stored in a table called file allocation table. File allocation table. Now, what are the file properties that you can find? File properties. One of them is the file name. The other is the location or the drive. Where is the information stored? What type of files are there? For system, they will support multiple types. The size, what capacity does it take in your disk? Yeah. Again, there is the aspect of protection. Is it protected or not? The date of creation, information about the file kept in the directory. They identify unique tag that identifies file within the file system. They are non-human. The unique identifiers are basically not human readable. The time, date, and user identification, you will find them in that particular file, or what you call the file properties. Now, when you look at the attributes are very, very different. The attributes, either it can be read-only, meaning that you cannot make changes. It can be hidden. You can hide the file from other people. It can be archived, or it can be system. Now, archive means you're storing it for backup. A system file attribute means that is a system file. And we all know that when a system file is basically used to booting. So, and that's why when you look at the definition of booting, you're saying that it is the process of loading system files into the main memory. That is booting. So when you look at the file attribute, if you find a file called a system file, it means that it is very important for the booting of your computer. Now, the typical operations that can be performed in a file. This was a question that was in the March series as we went through the paper. Typical operations: you can open, you can close, you can create, you can read, you can write, you can seek, you can copy, you can rename, and have a list. All those are some of the typical operations that can be performed in a file. So when you look at a file directory, basically we are talking about a folder. Yeah. But when you look at a file, it will have all these properties. You can find the attributes of a folder. You can find an attribute of a file. All of them will be there. Now we have various types of directories. Yeah. How can folders be? For example, there's somebody who asked if you have a folder that has many other folders inside it. That is a multi-level. A multi-level. If you have a folder, if you have your hard disk that has only one folder, that is a single level directory. You're only saving the information direct. Now let's look at the single level directory. Single level directory. You only have one directory. You cannot create two directories. You cannot create three directories. You only have one folder in short. Whether we are 1 million people, we can only save our work in that one folder. You cannot create any other folder. That is why it was called a single level directory. This was the old days when people were using the disk operating system as it began in the early 80s. People had to become very creative in naming their files because they were all... Yes.
I'm not understanding. Is it a symbol level directory or single?
Single, moja.
Oh, thank you.
Moja, single directory, where we are saying the users will only be saving their information in one folder or in one single level directory. Single level directory. Single, meaning that in that folder, the next thing you will save is your document or your file, either Word, Excel, Access, PowerPoint. So you can imagine the 50 something of you. Let me see how many you are. You are 58. The 58 of you, you want to save a single file called operating system. You'll find somebody calling operating system, operating system torrents, operating system, MOSE, you will have a problem of naming. And that was one of the biggest challenge that was there with the single level directory. So we're saying that it has a single directory for all users. And there was the problem of naming problem and grouping problem. Because all of us will tend to use the same name. So the problems are common as the number of files increases, and even as the number of users increases. And that becomes a major problem. So it's also difficult to remember unique names. It's not like the way you open your machine and you create a folder that has your name and the index number or admission number. In those days, there was nothing like ability to create other folders. So as the number of users increases, users must have unique names. And that was one of the biggest problem with single level directories. So the directory is basically, this in red is basically a folder. And in the folder now you have files. File for John, file for Tom, file for Mary, file for Kamau. Nothing more. You cannot add other folders. Now when you look at the two level, you have two levels. So you have what you call the master file directory, and you have a directory.
Excuse me, sir. Before you look at the two level.
Yes.
What is the major limitation on this single level?
The major limitation is naming problem, as I had mentioned here, and grouping problems. And then you have to be very creative in having unique names. So you'll have, if you have 100 people saving a Word document called operating system, you must make sure that people have unique names. Yeah. So you had the naming problems and grouping problem. For example, if I'm handling operating system for module for diploma, and I'm handling operating system for CICT, I will have a problem of grouping them because there is no way you can create a folder for DICT and a folder for CICT. Again, the naming problem. You have many people who may tend to use almost similar names. Exam, operating system. Everyone will tend to give almost similar names. And then you end up either duplicating the names or overwriting content of other people. So those are some of the problems that were with a single level directory. Now, that problem was solved by creating what you call the two level. Now, the two level means that, maybe somebody can mute the microphone. Now, at the two level, you'll find that you have what you call the master file directory. Now, the master file directory will allow you to create other directories within it, within the master file, meaning that with the first folder, now you can be able to create other folders inside it. Only at two levels. So you will have this as a folder, or what you call the master file directory, and inside it you can have this folder, and you can have another folder, you can have another folder, but you cannot create another folder inside another folder. There are only two levels. That was an advantage because, for example, we could have every one of us creating a folder here, another one folder, another folder, another folder, another folder. But after creating the second folder, you cannot be able to add more folders. You can only store your files. So it was introduced to remove the naming problem that existed in the single level. But again, still, it was a problem because at times you may need to create a folder inside another folder, like what you find in our day-to-day life. Yeah. Maybe you can just see whether I can be able to see maybe I'll be opening this in a short while, and then we'll be able to look at it in a short while. Now, this is the two level. So we're saying, since a user directory can be accessed via the master file directory, there is need to specify what you call the path name, since it's possible to have same file name for different users. You still had a problem because we all had to have unique directories. If this is directory number 1, this will be number 2, this will, another one number 3, another one John, and so on, so that we have unique directories within the master file directory. Now, if you look at that, we're saying here that information in each file user directory include the file name, the location, the type of file, the access control information, and administrative information. Those even exist today. You'll find them like that. Now with the multi-level directory, or why tree directory, I want to switch from this to those so that you have a look at, maybe I can explain this and then we can switch to the those, and then you'll see what you're talking about, the root directory. So we are saying in the root directory, this can be C, full colon, forward, the greater than the C. If, for example, you go to the root directory of C, it will be C. Let me just see here how it is. Maybe we can share this. Let me change the sharing. Let me share my DOS commander. I don't know. Can you be able to read this? Let me hear an answer. Can you be able to read this? No. It's a bit small, but is it legible? No. And then if I type the word tree, for example, tree, it is going to open the folders. All these are folders and subfolders within my laptop. Are we together? All those are files. It's opening the files and folders, subfolders, and files. That's what we call a tree. You can see there are many, yeah? Up to the end, yeah? Are we together? Yes. Now, this is the why we are calling it tree directory. Tree is an external DOS command. It's an external DOS command that is showing you the folders and the subfolders. Now, when I go to the DOS, let me go back to the DOS command again. Now, this is the root directory. If I come here, cd backslash, let's go cd dot. Now, this is the root directory of C. It is C full colon / and then the greater than sign. Yeah, this is the root directory of C. The root directory of C. This is the root directory of C. Yeah. So if I come to my Word document here and I share again, let me share again. Okay. Now, if I come to the root directory, this one, for example, if your machine has a drive called D, that will be the C, the full colon, / and then the greater than sign. That will be the root directory. Now, inside that root directory, you can have subdirectories. You can have as many directories, as many subdirectories. As you can see here, you will have the master directory. That could be the C or D, full colon, / and the greater than sign. And then you have many other subdirectories and many other files inside those subdirectories. This is where we are. For our mobile technology, for our laptops, for our tablets, you can create as many folders as the user wishes. And this is how we are able now to sort out the problem of naming and grouping problems. So we're saying here that most systems, such as MS-DOS, Windows, Unix, use the concept of multi-level structure in which directory entries may be a pointer either to a file or to another directory. So with this, the user can be able to create as many directories and as many files as the user wishes. That's why you can have a folder within another folder, and within that folder, another folder, and files within those folders, and so on and so on. So those are the three filing structures or the type of directories that you'll find. Either it can be a single level, it can be 2-level, it can be multi-level, or what you call hierarchical. Now, the advantages of the multi-level structure is that you will not have naming problem, you will not have grouping problem. There is privacy and security of user data, because users can be able to manage their information without any struggle, and that becomes a very major advantages. Now we have what you call deletion of directories. One option is, for example, I don't know how many of us have found a situation whereby you have a folder, but you cannot delete that folder unless you delete the content that is in the folder. Only deletes if directory is empty. That is the first option. And I believe many of us have seen that, yeah? Let me hear a yes or a no from your chat section. You found a situation whereby you're only able to delete the folder once you delete the files that are in the folder. But there are others you can be able to delete even everything without consideration of whether there are files or there are no files within that folder. Those are the two methods that we are talking about. So we are saying here that we have the deletion of directories, which is option number 1. Only deletes if the directory is empty. Number 2, deletes all files and subdirectories under the directory. That is where you say delete, and it deletes all the files and the folders that are inside what? That are inside the directory. Now we have the disadvantages. The length of part of which must be made through various directions. I think this is a misplaced statement. There's some files I deleted there. Now we have what you call file sharing security. File sharing security, access rights. And I believe all of us have this kind of access rights. Yeah, where we are saying different users will be able to. Now we're saying here that we have access rights, either for simultaneous access, so that if you're accessing information simultaneously, for example, in like now we are in Google, we could share files either in Google Drive or whatever. There are access rights involving the management of simultaneous access. Either in the supermarket, where we are accessing the same database, where we are picking the content of sugar or bread or whatever items. There must be rules to control what we call simultaneous access rights. Again, there are access rights for non-sharing environment, where only one person is allowed to access a file at a time. Like for example, this Word document, we cannot open it twice. It is only one person who can be able to access that file at a time. Again, we have when files are to be shared, a memory is required for specifying which user is allowed to access to the owner and which one is not. So the owner must specify what access privileges the users might. And I believe even in our day-to-day life, we have in our social platform, there are files that you have allowed X to see, you have files that you've allowed everybody to see, and you have files that you have already saved for your personal consumption. So we're saying these are some of the access controls. So you must specify the access privileges depending on different users. For example, even if you go to our new system, the enterprise resource planning system that was bought last year, the principal and the students have different access privileges. What you can be able to access from the portal and what the principal can be able to see are totally different. What the teacher can be able to see and what the head of department can be able to see are totally different. So it's important to note those access rights. And then we are saying here that you may also grant rights to others using the following criteria: specific user or user groups, or even you can allow some items to become public files where anybody can be able to access them. So all these are what you're calling access rights. And I believe we have interacted with these access rights differently. Please note that there is a difference between access rights and access levels. You remember the 3 access levels? The 3 access levels were either system, directory, and file level. And I think I differentiated between the 2. But here we are talking about what? Access rights. Access rights to a particular file when you're sharing. So those are the 4 main ones. Now we have what you call in simultaneous access. Users may lock the entire file, and I think I'd specified the aspect of locking a file, or you can lock a particular individual record, especially when you're doing a transactional sale in the supermarket. You will be locking individual records. But when you lock a file, it means that that entire file, like this document that I'm sharing now, if I lock it, it means that no one else can be able to access it. I hope that is understandable. So you can lock the entire file, or you can handle individual records. And record basically, for example, if I insert here a row, maybe this row here, and I say this is, for example, I say this is ADM, admission number. Maybe this is 001. And then I I insert another one here, I insert another row below, and I say this is 001, 002, for example. So when somebody is accessing this record, this is a record 001, maybe with the name, date of birth, the class, department, and so on and so on. When somebody is accessing this record, no other person should be able to access that record. That is, you're doing what you call, you're locking that particular record. But if you say you're locking an entire file, it means this entire file cannot be accessed by any other person when one person is accessing that particular file. So you should be able to differentiate between the two. Somebody is joining an hour and a half later. So we have typical access privileges, or what you call rights that may be granted, include none. No one should access this file. Yeah. So you can find that in Novell, you can find that in Unix. Knowledge, you know that it is there, and you know who is the owner. That is knowledge. Execution, one can be able to run. Reading, you can be able to access that content, but you cannot. You can be able to read independently. If you're given, but you cannot be able to. If it's reading, then you cannot be able to write. Now, when you say append, you can be able to modify, or you can be able to add the content. Yeah. Update, you can be able to modify, you can be able to delete. It's more of appending. Yeah. But appending now means you cannot be able to delete. But here we're saying if you're given the privilege of updating, it means you can modify, you can delete, and you can do any other activity that is allowed by whoever. Now, again, there is a change protection. Yeah, P, or we're saying that you can grant right for the file. Owner can specify what other users have right to the file. And then there is the aspect of deletion. You can be able to, all these are privileges that you can give to different users. For example, when you're accessing the college portal, what can you do? Yeah, you can be able to read, yeah, but you cannot be able to modify. You can only access information, but there's nothing you can do with that information, either modifying or deleting. Not unless it is your personal profile that you have been given the privilege of editing and modifying. That one is fine. But there are various access levels that are already there. Now we have what you call secondary memory organization stroke management. Secondary memory organization stroke management. Now on secondary, a file consists of a collection of blocks of data. The operating system of the file manages system responsible for allocating blocks to files. Now, secondary memory basically is storage that is outside or not the primary one that you have in your system. And you can manage it differently. And we're saying here that file storage space is generally allocated in fixed size blocks and so on and so on. Now, you remember when you're talking about the fixed size block, the memory is already pre-divided, either into 10 GB or maybe 5 GB, 5 GB, 5 GB, depending. So the organization may vary. Or you could also have what you call the dynamic technique, where the files are allocated storage or are allocated space on demand. So it will depend on the kind of organization that is already set for that particular storage. We have file allocation techniques that we'll be discussing here. File allocation. Now you have a file and you want to store it in a particular storage. How are you going to store that information? That is what you're calling the file allocation. Now, are those charts or what are those? Yeah. How can you remove a write protect on a USB or a mem card? Now, initially when you look at some of these flash disks, you can find others that have a small button that you can push it either to lock or you can push it in a different direction to allow writing, or you can remove the write protect. But for the USB, I don't know, unless it is programmed to be read only, they are supposed to be read and write. Yeah. So if you look at those flash disks, mostly they do have a switch. Yeah, a switch for you to either write or read, or you can be able to write protect. So it will depend on what kind you're having. Or you can even decide to format the disk, for example, if it was locked, if it is possible for you to do that. But you can check the options that are there. Now let's look at the file allocation. We have what we call the pre-allocation, and we have what we call a dynamic allocation. Pre-allocation means that, of course, there are some conditions that have already been set. By the time that file is to be stored, the storage media has some set conditions. Or if it is dynamic, then as the file comes, it is stored. So we are saying pre-allocation policy requires that the maximum size of the file be declared at the time of creation. It's more like you're declaring a variable in programming. We are saying, you're saying this is an integer. So the storage is already reserved for an integer. Yeah. So it will depend. It will depend. So again, if you're doing what you call dynamic allocation, it would mean that the allocation policy will be based on the need that particular file will require. So those are the two dynamics. And then we have what we call the portion size. Variable large contiguous portion can be used, which provide a better performance. You're providing bigger space than what that particular storage can use, and this avoid wastage of space, and the files allocation table is small. So variable large contiguous portions can be used. So portion size, where you're saying you're reserving certain amount of information to a particular file. Either it can be slightly bigger or than what is required, or it can be slightly lesser than what that particular file requires. So those are the two types of issues to consider in file allocation. Do you want to do what you call pre-allocation, or you're setting them to fixed, or you want to do dynamic? Are you going to have what you call portion size, where you're saying, I'm going to set maybe 15 MB for these types of files, and 20 MB for this type of files? That was called the portion size. Variable large contiguous portions can be used, which provide a better performance. Now let's look at the file allocation technique. This one we have already discussed, but in a different setting, when we're talking about memory management. Here we are talking about storage. So we're talking about the file allocation techniques. Now we have what you call contiguous memory allocation. Now in contiguous memory allocation, we are saying here that the system will allocate consecutive memory address. For example, if I come here, you will issue 2, 3, 4, and then if you have file B, it will be 9, 10, 11, 12. That is contiguous. So we are saying a memory allocation technique that assigns processes consecutive memory addresses. Very important. Now, when you look at the non-contiguous, is what we have down here. This is non-contiguous. File B, you will store the first portion in number 1, and then jump to number 8, jump to number 3, jump to number 14, jump to number 28. So you're using an index. You're using an index to jump from one block to the next block and to the other block. So these two methods are used, and they have their advantages and they have their own disadvantages. For example, if you're doing contiguous memory allocation and you're using consecutive memory addresses, it will mean that if there is a file that has already been allocated this particular memory, then it becomes difficult for you to continue expanding the size of file A. But if you're using non-contiguous, it means that you can hop from 3 to 8 to 17 to 29. It becomes easier. So let's look at the two in details. Now let's look at the consecutive, or what you're calling a contiguous memory allocation. They're saying here that a single contiguous set of blocks is assigned to a file when it is created. It is what we call a pre-allocation strategy. You already know that this particular file will require 10 blocks. So you reserve 10 blocks for that particular file. It is a pre-allocation. Of course, there is good performance because you're accessing consecutive files. Again, external fragmentation tend to occur. Why are we saying external fragmentation? Because if, for example, a file requires 5, and this is 1, 2, it can't fit here. It can't. Then you come to 5, 6, 7. This 2, it can't fit in this 4 because it needs 5. Then you will result to what you call external fragmentation. Yes, there is enough storage, but it is not contiguous. It is not contiguous. And that means you have what you call external fragmentation. How do you overcome this problem of external fragmentation? You may need what we call memory compaction, so that 0, 1, 5, 6, 7 are together. And then that file that required 5 can now be loaded into the main memory. And then now you have overcome the problem of external fragmentation. A process that is in the secondary storage cannot be loaded into the main memory because the memory blocks are not contiguous. So the only way to overcome that, you do what you call memory compaction, so that you combine the free spaces, the 0, 1, 5, 6, 7, 8 together, so that that particular file that is in the secondary storage can be loaded into the main memory. That is what we call contiguous. So we are saying here there is need to specify the size of the file at the time of creation, so that you can be able to conserve or preserve consecutive memory addresses. You can be able to preserve consecutive memory addresses for that particular file. And that becomes a big problem. Number two, we have what you're calling chained. We have what you call chained. Let me push this down. Now with the chained allocation, it is an individual block basis, where we're saying it doesn't require to be consecutive memory addresses. We are saying you're making use of pointers. Each block, like number 1 here, will have a pointer to number 8. Number 8 will have a pointer to number 3. Number 3 will have a pointer to number 14. Number 14 will have a pointer to number 28. So we are saying here that in the chained allocation method, or what you're referring to, non-contiguous memory allocation, it becomes an advantage because the file can continue to grow irrespective of the available storage, because it can be stored in whichever block that is available. So we're saying here that allocate on the basis of individual block. Yeah, there is no external fragmentation. Why? Because a file that is in the secondary storage can actually be brought on board in whichever block that is available at whichever location, and that becomes an advantage. So we're saying best suited for sequential file, yeah, where you want to access that information differently. So no accommodation for locality. Now the problem of you remember we talked about the principle of locality. You're not going to utilize 0, 1, 2, 3, 4, 5, 6. You can use whichever available block at whichever storage that is there. Now, if you want to make sure that the information is consecutive, then you can do what you call the reorganization of your files, or compaction, so that these free holes can be continuous, and that can be done to have this kind of a storage. So we're saying to overcome this problem, files are consolidated by some systems, and that can be done, but that will be an overhead to the CPU. Number 3, we have what you call index.
Excuse me.
Allocation. Yes.
And chained allocation.
Yes.
There is an issue of giving direction from the starting point only. What does that one mean?
Because for you to have a starting point for any file, you must have the starting point. As long as you don't know the starting point, you're lost.
Okay.
But if you know the starting point, then the pointers can guide you to the next blocks that are related to that particular file. So the file just need a single entry to that particular file, and then you can be directed by the pointers to the rest of the other files.
So thank you.
Okay. Now we have index allocation method, and basically we're now going back to what we talked about, indexes. So we are saying that in this case, a file allocation table contains a specific one-level index. If you look at this diagram, you have a one-level index here. Now, in this number 24, it is going to give us direction to all the other blocks that are associated to a particular file. It's like walking into a 50-story building, and in the ground floor, you have a direction chart showing you that first floor, we have this and this and this and this and this. Second floor, we have this and this and this and this. So you can be able to have what you call direct access to whichever information that is stored. So we are saying here that in the index allocation, maybe somebody can mute their microphones. So we are saying file indexes are not physically stored as part of the file allocation table. Rather, the file index is kept in separate block, and the entry for the file in the VAT point is the block. Allocation may be on the basis of either the size of the block or variable partition. Now let's look at this diagram here. We are talking about the index allocation method. Now in the index allocation method, we are saying there will be a block that is reserved to give direction where information is stored. Now we are saying here that file allocation table contain one level index for each file. So for example, this is for file B. Are we together? If we need another file C here in 15, it will have another index block that will direct us to where all the other blocks of file C are contained. So if 15 is our index block, then it will give us direction to all the other blocks that are related to that particular file. That becomes a challenge, because if you have so many small files, then you have so many blocks that are wasted for index, and that end up reducing your storage. So typically the file index are not stored as part of the allocation table. So that means we have what we call the index block, and we have again the file allocation, the allocation table. So there'll be a lot of duplicate in terms of how to access information. So you can use both sequential and random access. Again, in the figure above, a fixed size block allocation schema is presented. It eliminates the problem of external fragmentation, because you only need one point, and then the information can hop to whichever location or onto whichever block. Any question this far?
Question.
Yes, yes.
This is Torrance.
Yes.
My phone went off, so I'm using my fellow's phone.
Yes,
so
yes.
I'm asking this index allocation.
Yes.
We are saying that the blocks are too small and
Yes.
cannot have to hold many pointers. So I was asking.
Yes.
How can we? How are we able to help in this situation?
And what I was meaning is that, for example, if you have a file that has only stored information in two blocks. For example, if we have an index blocks for file C, and that file C has only two blocks, then it will mean that we'll have wasted this block to give direction for maybe 10 and 5. If you have another file that has only one block, then you will have to waste this block to be an index to show direction that file D is only having a block number 21. So you end up wasting a lot of storage on these index blocks, and that becomes a disadvantage. And again, at the same time, you're maintaining what? The file allocation table. You see here the file allocation table.
Yes.
Now you have the file allocation table for the entire information, file B, and then you have an index block. So you're duplicating the control information for every file, and that indeed wastes a lot of storage. I don't know whether I've answered your question.
So I was thinking that the possible solution using the linked schemes, the multi-level index, and the combined schemes.
Yes, you can, but you see, this is a different allocation method, but it will depend now on the kind of storage. But your proposal can still stand.
Okay.
Yeah.
Thank you.
But basically, when you have pointers, they are better. Yeah.
Yes.
Or when you're talking about the chained allocation, is better. It's better because from one entry point, and of course, the information is also contained in the file allocation table. You see the file allocation table?
Yes.
The file allocation table is giving you the file name, the starting block, and the length. Now let's look at the file system integrity. We're saying that it's essential that the file system provide adequate mechanism for backup and recovery. Very important. Ensure that we are saying here that every file system must make sure that it has a mechanism for for backup and recovery. Otherwise, you'll have a problem of losing your files. And that is why we shall be talking about the RAID technology. Random redundancy, we call it RAID, redundant array of independent disk. Are you going to use RAID 0? Are you going to use RAID 1? Are you going to use RAID 2, 3, 4, and even RAID 10, depending. So you must have a mechanism of making sure that you're able to back up and you're able to recover. So this means that the system must maintain duplicate copies of the file. And this is basically done for the servers using RAID 1, where you're creating you're mirroring disk 1 with another disk. And that becomes an advantage. Now, we talked about the ways of backing up. You remember in our revision, for those people who came, we talked about full backup, we have incremental, we have differential copies, and we have daily. This one I'm not going to repeat because we handled them in our last March, April 2020 exam that was done. So we have these terms that you'll always find, especially when you're dealing with files. We have authentication, we have protection, and we have security policy. Authentication is an activity to make sure that you're exactly who you say you are. It can be either using your username and password. Protection is a mechanism in an OS that checks whether the subject is allowed to perform an operation. And you can that is done by different access control levels to ensure protection. Security policies. These are rules that the protection mechanisms that will enforce that are enforced. Yeah. They are security rules that the protection mechanisms used to enforce safety. Policies, yeah. So we're saying here that these are security rules that the protection mechanism used to enforce safety. Now we have modern cryptography. If you look at the modern way of encrypting information, we have different methods of encrypting information or cryptography. Now we're saying here cryptography is a science of secret codes, creating codes and breaking codes. This is done in computers. Now, with the advent of computer, we're saying that we have various methods of encrypting information, whether in storage or in transmission. Yeah. For example, if you're transmitting information from Kenya to Somalia, or from Somalia to Kenya, there are various encryption methods in data communication, and there are various encryption methods even in data that is stored. Those are what we call the modern cryptography. But I think we shall be discussing some of this in data communication. Yeah, in data communication. So those are the modern cryptography. We discussed this spatial allocation, and we talked about sequential allocation. Yeah, spatial allocation. This is where there is a tendency for the process to access items whose addresses are near one area. Sequential allocation. This is where reference to instructions and to data tend to follow a certain sequence. I think those ones we've already talked about them. Now, what are file types? I believe these ones. This was a question somewhere. Yeah. So we're saying file types refer to the classifying the content of files, such as program, text, executable files, or data files. So we have different types of files. It can be a program. It can be text. It can be executable. Executable means it can run. Program, it means it is sorry, we have executable files that is running, or we have what we call the data files. And I believe if you look at, yes.
Can't you repeat the explanation about the file types?
The file types. Now,
yeah.
When you look at the various types of files, you can find that you can have a system file. That is number one. You can have a text file. You can have an executable file. An executable file means that it can run. For example, if you're writing a program in Pascal, that is an executable file. You can run it to do a particular operation. Maybe ask the user to enter data on the screen or do an arithmetic operation. So it will depend. So we're saying here that there are various classification of these files. So you can have such as a program file, Now, program files are the ones that we are running, like in the Word, Excel, Access, and so on. And they have different extensions. You see here the extension, they are different. You can have PPT, you can have PDF, you can have the DOC, you can have PDF, and so on and so on. Those are program files. Now, we have text files. Of course, they will be TXT. You have what you call executable file. They will have an extension of .exe, the executable files. And we have what you call, and they have the extension, like you can see here. If you find one that has .bse, it is a basic file program. .c is a C source program. .dll, basically these are for the system library, mostly for the system files. For the DOC, Word document. If you find PDF, they are portable document files. If you find like, which other files do you see? PPT, that is a PowerPoint. So there are many. There are many types of these files.
So if you include directory files.
What do you mean directory files?
Yes.
What do you mean by directory? A directory is a folder. A folder. A folder does not have an extension. For example, if I say PPT,
Yes.
if I say, for example, .ppt, that is PowerPoint, yeah?
Yeah.
PowerPoint, yeah? Which other extensions do we know? There are many extensions, yeah?
Yeah.
For example, if I'm opening a database, what extension will I find? .pp, yeah? That is a database, yeah? A database. But there are many extensions. So these files, we have various types of files, yeah? And they have various types of extensions. Any queries this far? We can go back to the question that was already asked previously. Okay, there was a question here. We have .bat. Okay, somebody's coming in when we are leaving. Douglas is coming when we are leaving. Yeah. So let's look at the term file metaphor and see whether we will be able to get the definition. Desktop. Let's see, file metaphor. So we're saying here that I'm just looking at some of the definitions that I'm trying to get here for the file metaphor. Just let me see whether I'm able to. I don't know whether I have better definition for this. Okay, I'm just trying to look at. I'm trying to Google that term somewhere. And
I have a try.
Yes.
So we can say that the file metaphor,
Yes.
a way of helping users to keep the tracks of something for easy access.
Sorry, a file metaphor?
File metaphor.
Yes.
An easy way to help user keep tracks of where something can be found.
Okay, so it's a way to enhance locating files.
Yes.
Okay, that's good. Now we have a few minutes. If you have a question, you can ask. Yes.
So paging. What is paging?
Now, when you talk about paging, I think we discussed about it when we were talking about memory management, and we said paging is either it can be either simple paging or just paging. Is a mechanism in memory management that divides memory into. We talked about you're either dividing. You have your program. You're dividing it into pages, and you have your memory. You're dividing it into frames. And I think we have it here when we were talking about paging and segmentation. Control F. So you're dividing your program. You're dividing your program into a number of equal sizes so that you want to minimize the problem of internal fragmentation. Yeah. So you have two paging. You're dividing memory. You're dividing the process into pages and memory into frames. Now, when you look at this diagram, we say that you have your process and you have your memory here. This is your memory space. You look at this. So you're dividing your process to making sure that page 1 goes to maybe a particular memory location, A1. That will result to minimal internal fragmentation. So we say here paging is the process where you're dividing your process into pages and memory into frame of equal sizes to minimize the challenge of internal fragmentation. And I think we talked about it. So you can find either simple paging or just paging. Now, when you talk about segmentation, it's slightly different. Now, in segmentation, we said here that the process and memory are divided into variable chunks. So you may not find a scenario where the memory is divided into equal portions or the process is divided into equal portions. No, the memory is divided into variable chunks and the process can be loaded into whichever chunk that will easily fit with minimal slack spaces. Was there any other question that was asked in our previous discussion?
Excuse me.
Yes.
Right. Hello.
Yes.
Excuse me. Are chunks the same as frames? Are chunks the same as frames?
Okay, it depends. Chunk is a general word, yeah. But when you specify frame, for example, if I say chunk is a general term. But when I say frame, is basically dividing memory into equal sizes that we are calling frames. And I say when I say that I'm dividing my process into pages, it means that I'm dividing my program into modules of equal sizes that we are calling what? Pages. But a chunk is a general term. It's neither here nor there.
Thank you.
Yeah.
Hello, sir.
Yes.
On a strategy of fragmenting free space,
yes.
What's made by the worst fit?
The worst fit?
Yeah, option number 4.
I can try.
Okay.
I can try.
Yes, yes.
In the worst fit, the memory manager places the process in the largest block.
That is very true. That will result to the biggest hole that remains after placement.
Thank you.
We are waiting for Douglas. We're waiting for Douglas. Once he types the question, then we can, if there's somebody else, you can still type your question, and then we'll have done with that topic. God willing, in the next lesson on Thursday.
I have a question.
Yes, yes.
What is demand paging?
Now, demand paging means that. Now, with the demand paging, it means that the paging itself is done on demand. That means that the memory is not pre-divided in advance. The memory is pre-divided based on the demand of a particular process. That is what we call demand paging. But in the normal paging, the memory is divided earlier into fixed page frames. And the process again, as the process
kitu bana. Ama bado imeisha.
Douglas, we're waiting for you to finish typing your question. So demand paging, we are saying here that the paging itself is done depending on the type of process that is being loaded. But in the normal simple paging, the division is done earlier in advance. It's like partitioning your hard disk. You don't decide to partition it when you're running a particular program. You partition it earlier in advance, and then the user will have to stick with the current partitions. With demand paging, now that changes the matrix, that you will be dividing your memory based on the process that is being loaded into the main memory. It requires 10, 10, 10, 10, 10. You divide memory at that point 10, 10, 10, 10, and minimize the challenges of internal fragmentation.
What of demand segmentation?
It's the same. It's still segmentation, yes, but now you're handling the same on demand. So whether you talk about segmentation, you talk about simple paging, or you talk about demand paging, they are all reflecting the same thing. But now, when is that segmentation done?
Excuse me.
Yes.
I understand that we have two types of interruption.
Types of interrupts.
Yeah, mask and unmaskable.
Yes.
And an unmaskable,
Yes.
you said that this cannot be ignored.
Non-maskable interrupts
Cannot be ignored.
Yes, they
What
cannot
are
be ignored.
what are some of examples of these interruptions?
Not interruption, some of these interrupts.
Yeah, interrupt. Sorry.
Yeah, now, when you talk about non-maskable, it means that they cannot be ignored, meaning that they are interrupts that are very essential for the running of your system. For example,
Okay.
if you have a problem with your operating system,
Yeah.
and there is an interrupt for you to handle a particular request, either to allow the system to download a particular patch so that your operating system can run, then that would be an unmaskable interrupt.
Okay,
But
understood.
Yes, but if it is music, that
Yeah.
one can be ignored. Yeah.
Okay, understood. Thank you.
Okay. Douglas, we are waiting for you to finish typing. Are you typing a whole question?
I have already typed.
Oh, it's down there. Deadlock occurs when the process or a thread enters into a waiting state because a requested system resource is held by another waiting process, which in turn is waiting for another resource held by another waiting process. That is circular wait condition. Because we have four types of, can you discuss address map? Sorry, this is Douglas. Huh? Can you discuss address map and the base limit registers briefly? Now, when you talk about, let me answer the question that was asked by, again, Douglas and Douglas. You've typed two, yeah. Let me begin with the first question with that was typed by Musembi. Now we have four conditions necessary for a deadlock. One of them is what we call the circular wait condition, where a resource is held by another process, and that process is holding a resource and it is waiting for another resource that is being held by another resource, by another process, sorry, and that process is holding a resource and waiting to be assigned another resource that is held by another process. That's what we call circular wait condition. Now,
Excuse?
yes.
Is circular wait the same as hold and wait?
Now, hold and wait means a process is holding a resource and it is waiting to be assigned another resource. That is what we call hold and wait. But now in the circular wait, you have to have two or more processes that are holding resource and are waiting. Like now the question that is being discussed here, where we're saying that we are saying here, okay, when the process or a thread enters a waiting state. Now a resource is held by another process, by another waiting process, which in turn is waiting for another resource held by another waiting process. That is now what we call circular wait condition.
Okay, thank you.
Yes. Now let's look at the question that Douglas was asking. Can you discuss address map and what you call the base limit register? Now the base limit register, basically we have what you call the two types of registers when you want to enhance protection. We have the base and we have the limit registers. Now the base register indicates the beginning or the memory, the starting memory address, while the limit register indicates the last address of that particular process. And that's how we enhance what? Protection. So the base register is indicating the start addresses, while the limit register is indicating the end of that particular register. So those are the two. So the purposes of having this register is to enhance protection. And you remember it was one of the 5 objectives of memory management. Protection was one of them. You remember we have protection, relocation, logical and physical organization. You remember they were there. So for you to enhance protection in a multi-programming environment, you must ensure that you have what you call the base and the limit register to enhance protection. Any other query? Okay, if there is no other query, allow me to call it a day. And I wish you well. At least we had, this is almost a third of the class. A third of the class. But anyway, I wish you well. We'll meet again and we will handle another topic, God willing, on, is it on Thursday?
Yes, Thursday.
Thursday, what time? In the morning?
Yeah, morning time.
Let's keep time. I have a meeting. It's on Friday.
It's on Friday morning.
Friday morning.
Friday, 8 to 10.
Ah, that's fine. Because on Friday, on Thursday, have a meeting. So we meet on time
Request.
and encourage others to come on board. I wish you well. Let's meet again on Friday.
Requester.
Yes.
Can you send us the soft copy of the notes?
Yes, I had already sent, but I can send you even these ones now.
Send this one.
I'll push them in the group right away.
Thank you.
Okay.